Hi students, welcome back to our channel. This is Kumar, and in today's video we are going to discuss about coordinate geometry, and this is a part 1 video where we will discuss the introduction part as well as the distance between 2 points in the coordinate system, distance between 2 points in a coordinate system. Now what is coordinate geometry? What is a coordinate geometry? It is also called analytical geometry. Analytical geometry is called analytical geometry. What is analytical geometry means? It is the method of studying about the geometrical figures and its corresponding equations in a coordinate system. So how many type of coordinates we are having? Means we are having a 2D as well as 3D. So 2D denotes 2 dimensions, 3 dimensions, 2-dimensional coordinate system as well as 3-dimensional coordinate system. In this we are going to discuss about the 2-dimensional coordinate system, and this was introduced by René Descartes. He was a French mathematician. Since we are discussing about the geometrical figures in a 2-dimension, so it is called a 2-dimensional coordinate system. It is called a coordinate geometry. Now you see two things which was discovered by René Descartes. So he discovered two things. The first one, in any space or in any plane, an ordered pair of numbers can be represented by a point. The first thing he discovered that any ordered pair of numbers can be represented by a point in a plane. And second thing, any curve in a 2-dimensional coordinate system, any curve can be expressed in terms of x and y. Any curve can be expressed in terms of x and y in a 2-dimensional coordinate system. So these things he discovered, and the first thing we will discuss now about. So as I said that ordered pair of numbers is represented by a point. In a plane. So let us take a plane surface. So in order to represent a point with the ordered pair of numbers, divided the plane into 4 parts, taking 2 reference lines. So these reference lines are intersected at a point called origin. This is called origin. This point is called origin, and the horizontal reference line is called x-axis. The vertical reference line is called y-axis. Now this plane was divided into 4 parts, and each part is called quadrant. Here a quadrant. Now this point we have taken as a point P, x comma y. It says that the distance of this point from y-axis is x coordinate, which is called abscissa. And the distance of the same point from x-axis is the y coordinate, that is y. So it is called here ordinate. coordinate. In a point, the first x is called abscissa and y is called a ordinate. Y is called a ordinate. Now, this plane surface is divided into four parts, and each part we are calling as a quadrant. So the first part is called a quadrant 1, second one quadrant 2, third quadrant 3, fourth quadrant 4. If you observe here, in the first quadrant, both x and y axes are positive. Both x and y coordinates are positive. When you project the same point on the same point in the second quadrant, then the coordinates are x is negative as well as y is positive. So minus x comma y. This point becomes a minus x comma y. When you project this point in the third quadrant, the third quadrant x is negative as well as y is negative. The coordinates of the point will become minus x comma minus y. When you project this point in the fourth quadrant, the coordinates, if you observe, where x is positive and y is negative, so the coordinates becomes x positive and y negative. This is about the introduction part. Now we'll see the distance between two points in this coordinate system. We'll see distance between any two points in the coordinate system. Distance between two points. Take the coordinate system. X-axis, y-axis. Now consider two points here on the coordinate system. Since we are deriving for a formula for distance between two points, and take 2 points on the coordinate system. The first point is A, whose coordinates I am taking as x1 comma y1, and the second point we are taking as B, whose coordinates are x2 comma y2. Now we need to find the distance between these 2 points A, B. The distance between 2 points is generally denoted by, if I am taking those 2 points as AB, then it is denoted with AB. Right? Now project these 2 points on the respective y-axis as well as x-axis. 2 points, project them on x-axis as well as on y-axis. So it shows the distances of the point from y-axis as well as from x-axis. That is x1. This total distance is x2. This distance is y1 and this total distance is y2. Now if you observe the point between A and B which are projected on x-axis, the gap between them is x2 minus x1. Since the total distance is x2 and a part of it is x1, the remaining distance will be x2 minus x1. In the same way, when you observe the projections on the y-axis, the total distance is y2 and a part of it is y1, then the remaining distance will be y2 minus y1. Now construct a horizontal line at point A. Just extend, which is passing through point A, horizontal, which is parallel to the horizontal line. Now if you observe clearly, as you are taking projections, it will be perpendicular. So here it is making a triangle, right angle triangle. So this point of intersection, let us assume that is some C, point C. Now from the triangle ABC, we came to know that it is a right angle triangle. So we are having two distances. That is its AC distance we are having as x2 minus x1, and BC distance we are having as y2 minus y1. So we need to find the distance between A and B. So we already have a Pythagoras condition, which is the square of the hypotenuse. That is hypotenuse here it is AB. So AB square is equal to sum of squares of the remaining two sides. That is sum of squares is AC square plus BC square. Now replace the value AC value. What is AC distance? X2 minus x1. X2 minus x1. So x2 minus x1 whole square, since it is having whole square, so whole square, plus BC. BC is y2 minus y1, so y2 minus y1 whole square, so whole square. So but we want the distance between AB, not AB square, so we need to find the AB value. So AB is equal to, AB distance is equal to, when sending the square on the other side, or equality becomes a square root. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula to find the distance between any 2 points in a coordinate system. Distance between any 2 points in a coordinate system. Now based on this formula and based on the different type of points, how the formula will be changing, let us see now. Just now we derived the distance between 2 points AB is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. If I take a minus common here, even if I take minus common, since it is having an even power, it becomes a positive. So even if I take minus as common, so it gets a positive. So my x1 minus x2 whole square plus y1 minus y2 whole square. So both are correct. Even we can write the distance between 2 points as x1 minus x2 whole square plus y1 minus y2 whole square. Now, as we have taken those 2 points, A as x1 comma y1 and B x2 comma y2. The distance between the 2 points we are writing as the formula. Now, if I take point A as origin and point B with some coordinates x comma y, how the formula is changing, we'll see now. Now this formula becomes AB is equal to, as x1 and x2, x1 is 0, x2 is x, y1 is 0, y2 is y. Now replace those values, simply you will get under root of x square plus y square, under root of x square plus y square. Now we will see one problem based on this distance between 2 points. If the point A is 1 comma 2 and point B is 3 comma 4. Now we will see applying the first formula. So AB is equal to under root of, this becomes x1 y1, this becomes x2 y2. Now simply substitute the values in the formula, that is x2 minus x1 3 minus 1 whole square plus 4 minus 2 whole square. So which will be equal to 2 square plus 2 square, which is equal to under root of 4 plus 4, which is equal to under root of 8 units. Never forget to write the units. If they are giving any units, you have to mention. If they are not giving any units, just mention units. Since it is a distance, it contains some units. So mention as a units. It is very important. Now, what happens if the 2 points lies on the coordinate axis? So the coordinate axis I have taken, one is x-axis, y-axis. The same axis, in the same coordinate axis, if I take 2 points A and B. So how I can calculate the distance between these 2 points? If you clearly observe the points, they are lying on the x-axis, the coordinates will be x1 comma 0 as well as some x2 comma 0. So what you can observe from this point is that the y coordinate is always 0 on the x-axis. So the y coordinate is always 0 on the x-axis. So the distance between the points on the x-axis, not only on the x-axis, which are parallel to the x-axis. Now we have considered the 2 points on the x-axis. The distance between these 2 points, if you apply the same formula, you will get a modulus of x2 minus x1. Remember, not only on the x-axis, if these points lie on a line which are parallel to x-axis, then also you will use the same formula. You will get the same formula. And if the points, if they lie on a y-axis, these points coordinates will be like x coordinate will be 0. So 0 comma y1, 0 comma y2. Now the distance between these 2 points CD will be modulus of y2 minus y1. This is all about the distance between 2 points. Okay, now we will discuss about where this distance between 2 points is used in different type of questions. So the first model is collinear points. So what are collinear points? The collinear points are the points, a set of points which lie on the same straight line. Are called collinear points. The set of points which lie on the same straight line are called collinear points. Now, how to identify whether the given 3 points are collinear or not? There are 3 points A, B, C. Now these 3 points are collinear or not? How to identify using the distance between 2 points? If you clearly observe here, the distance between AB, and if you add the distance between BC, then it should result the distance between A and C. So that is the condition. If they are in an order A, B, C, A after B and B after C, then the condition must be AB plus BC should result in the distance between A and C. So as the points are given and they are in an order A after B and B after C, then the condition will be AB plus BC is equal to AC. If the points are not in any order, they didn't mention whether they are in an order or not, then we can identify by taking the distances between the points. That is, you will find the distances between AB, BC as well as AC. You need to check sum of any 2 distances is resulting the third distance or not. You need to find all the distances individually, then add the distances. Sum of any 2 distances should result in the third result. Then we can conclude those 3 points are collinear. So the other conditions may be AB plus. The other conditions may be they may be in an order B, C, A, B, C, A. Then we can get that BC plus AC will result AB. In the same way, if the points are like C, A, B, then we can say that AC plus AB will result BC. So if the points are in which order we cannot say. So if they mention that the points are in an order A after B and B after C, then straightforwardly we can use this condition that AB plus BC is equal to AC. So unless an order is given, we can find the distances between the points. Then sum of any two distances should result in the third distance. So then we can conclude that the given points are collinear. This is one process where we use the distance between two points. And next one, and second one, to identify the type of triangle. Type of triangle. Type of triangle. Now, for triangle, we are having three vertices. So, if they are giving vertices x1 comma y1 a and b x2 comma y2 and c some x3 comma y3. Three vertices are given. Now what we are doing, we are finding the distances between AB, BC as well as AC. All three distances. If they are not collinear, if the first condition is not satisfied, if given 3 points are not collinear, then it may form a triangle. Three non-collinear points can form a triangle. Non-collinear points can form a triangle. Now, if these 3 points, how we are identifying? That if the distances are equal, all three distances are equal, then we can say it forms an equilateral triangle. Equilateral triangle. Even we have to identify if the distances are found. First of all, it forms a triangle or not. In the case they are giving that it all these three vertices forms a triangle, then we directly take the distances between the points. Then we will check for the conditions. If they didn't mention whether the points are collinear or they form the triangle or not, then if these points are forming a triangle or not, for that we are having a condition that sum of two sides must be greater than the third side. That sum of two distances, two lengths in a triangle must be greater than the third side, and difference between any two sides in the triangle should be less than the third side. If all these conditions are satisfied, then we can say that the given set of 3 points can form a triangle. So our question is like, if these 3 points forms a triangle, then how to identify which type of triangle it is? Now, after finding all the three distances, if all the three distances are equal, then it is called equilateral triangle. Suppose if only two sides are equal and third one is not equal, only two lengths are equal, then it is called isosceles triangle. Now, if all three distances are not equal, it is called a scaling triangle. AB is not equals to BC not equals to AC. Then if all three sides of the triangle are different, it is called a scaling triangle. And one more condition we are having, that is, if two sides are equal, suppose two sides are equal, we are saying it is an isosceles triangle. And if it satisfies the Pythagoras condition, that is the hypotenuse, the largest side. Suppose if AC is the largest side, then AC square will be equal to AB square plus BC square. AC square is equal to AB square plus BC square. If this condition is satisfied, then this triangle may it also called as a right angled isosceles triangle. isosceles triangle. If if the Pythagoras condition is satisfied for isosceles triangle, it is called a right angled isosceles triangle. So in these cases we are going to use the distance between 2 points formula to identify which type of triangle it is. If at all it is not collinear points, if the given 3 points are not collinear and if they form a triangle, then we can check which type of triangle it is by taking by looking at these conditions, right? Now one more thing is that the third one, that is type of quadrilateral. Type of quadrilateral. Type of quadrilateral. Now, in for a quadrilateral, we are having 4 vertices, that is A, B, C, as well as D. Now, if we are calculating the distances, all distances, that is AB, BC, CD, and AD. All 4 distances we have covered. Since it is a quadrilateral, 4-sided polygon, closed figure. So we get 4 lengths A, B, C, CD, and AB. Now, if all these 4 lengths are equal, then we get two conclusions. One, it may be a square. It may be a square, or it may be a rhombus. Now, how to identify when all lengths are equal? We are getting two conclusions. One is a square and one is rhombus. Then how to identify which is square and which is a rhombus? Whether it is a square or rhombus. Now, what we have to do? Then find the diagonal lengths, the distance between the diagonals, that is AC and BD. If AC length is equal to BD, if the diagonal lengths are equal, then it is called a square. And in case of rhombus, the diagonal lengths are not equal. Now, coming to the another condition, what happens if the all distances are found and if opposite distances are equal? In the first case, we are having all the distances are equal. Now, in the second case, what happens if opposite sides are equal? Now, we will see that AB is equal to CD and BC is equal to AD. Here also we are having two conditions from this. The first one is a rectangle. The second one is a parallelogram. So, which is called how to identify whether it is a rectangle or parallelogram? Again, we will calculate for the diagonal lengths. Where if the diagonal lengths are equal, that is AC is equal to BD, it is called a rectangle. If the diagonal lengths are not equal, it is called a parallelogram. So, in all these types, we are going to use the distance between 2 points formula. Hope everyone understood the concept. And if you are having any doubts regarding this concept, please comment in the comment section. And please subscribe our channel, like this video and share this video, so that everyone can see and everyone can learn this concept. Thank you so much.